in last lecture, we were discuss about there are types of a model. There are four types. Two are of a quantitative and two are of a qualitative models. And if you write in a matrix notation, the linear models can be written as y is equal to x beta plus epsilon, where y is having n elements, y1, y2, yn, and beta having a two parameters, beta 0 and beta 1, and x having a two column, one column of 111, it is for the coefficient of beta 0, and beta 1 is the coefficient of x1, x2, xn, and epsilon having a n element, epsilon 1, epsilon 2, epsilon n. So we usually assume that expectation of epsilon is 0 and variance of epsilon is a variance covariance sigma. But suppose the same models, instead of you have a simple linear models, you can have a more than one variables are in the models. So you can also write the general linear models in the following way. Consider the n equation yi equal to beta 1 x1i or xi1 xi1 plus beta 2 xi2 up to how many? So let us say you have a three variables, beta xip plus epsilon I, where I running from 1 to n, and expectation of epsilon I is given 0 for every I. So this is the same you can write in this structure. Yi is equal to how many variables? We have a p variables, so summation j running from 1 to p, beta j xij plus epsilon I, where I running from 1 to n, because there are n observations. So of course, what we have the assumptions, yi's are observable random variables, xij's are observable, they are also observable but non-random, or you can say it is a fixed non-random variables. From specific domain. So from domain, let us say D is a domain. 3. Beta j's are unknown parameters. Of course, they are from unknown parameters defined in parametric space omega, beta, epsilon I are unobservable. Random variable such that the covariance between epsilon I and epsilon j is equal to 0. I and I dash instead of j, because j we have used, it is a epsilon I dash is, we say it is a sigma I dash. Okay, in good writing, let us say covariance between epsilon I and epsilon I dash. अभी यहाँ पे हम ऐसा नहीं करें कि कोवेरियंस बिटवीन एप्सिलॉन आई एंड एप्सिलॉन आई डैश आर जीरो. ओके, वो एजम्पशन हम बाद में रखते हैं कि दे आर इंडिपेंडेंटली डिस्ट्रीब्यूटेड. तो वी आर राइटिंग जनरल फॉर्म. इन मैट्रिक्स नोटेशन सेम थिंग. Y is equal to x beta plus epsilon. Okay, where y is y1, y2, yn. It is the order of n cross 1. X is x11, x12, x1p, x21, x22, x2p. How many variable you have? N observation. So it is a xn1, xn2, xnp. So of course it is the order of n cross p. Epsilon having a n element, it is also n cross 1, and beta having how many elements? It is a p elements, beta 1, beta 2, up to beta p, because there are p parameters. Okay. So the same thing, y are observable. It means here we say that yes.
सर मेरा मोबाइल हैंग हो रहा है. मैंने फ्रेंड के मोबाइल से ज्वाइन किया है.
चलेगा.
वो सीनियर है.
हाँ, तो मैंने अलाउ तो किया पाटिल को.
हाँ ओके. नहीं अभी अलाउड नहीं हो रहा था इसलिए बोला मैं.
So y is n cross 1 observable random vector. Y is a random. Of course, y1, y2, yn are observable random variables. So here y is a vector of order n cross n, n cross 1. Similarly, x is n cross p. It is a matrix of order n cross p of fixed observable numbers. That means they are observable, but they are not random, so they are fixed observable numbers. That is, the element of x are not random. So if you compare the linear models with the regression models, so here x are random in a regression, however in a linear models it is a fix. So that is the only difference between the linear models and regression. Beta is p cross 1 vector of parameters. Of course, when you say the parameters, so they are unknown but fixed, defined in parametric space omega. epsilon is n cross 1 vector of unobservable random variables such that whose mean is 0, that is expected value of epsilon is 0, and variance of epsilon is you are writing in the form of a variance covariance matrix sigma. Because here we are not saying that the whether the diagonal elements are same, off diagonals are different. We are not saying anything. Once we put the assumption variance of epsilon is sigma square in, so the model becomes the homoscedastic. Okay, so we'll come to later. So this is about the these four assumptions will introduce the general linear models. So whatever the models we have written this y is equal to x beta plus epsilon, where x y is equal to y1 y2 y and x is and epsilon beta has this form, and y is observed, x is of order n cross p, but it is a fixed, beta is a p cross 1 vector of unknown parameters, and epsilon is a unobservable quantity of order n cross 1, and it is a random whose mean is 0 and variance covariance matrix is sigma is defined the general linear model. So now if we talk about the second model, this is about we wrote talk about the linear models. Now second is linear regression models. If you are writing in a matrix notation, then the linear model is said to be a general linear model. So what are the difference between the linear models and regression models? I said all the assumptions remain the same except in linear model x are fixed, however in linear regression models x are random. A linear regression model different from general linear models different from general linear models in the way that in general linear models इसको हम GLM कहते हैं, general linear model independent variable. So what are the independent variables? They are x independent variables, that is x, are fixed, or you can say it is a non-random, while in linear regression model x are random. Rest of the things remain the same. So this we discuss about the quantitative models. Now we talk about the qualitative models. So I said that two qualitative models we will discuss. One is a design models and second one is a variance component models. But this qualitative model is based on the nature of x. Y must be quantitative. The qualitative and quantitative models model refers to the predictor or independent variable x. So independent variable is also known as the predictors or independent variables x used in the model. So here in the second semester, whatever models we are saying that they are qualitative and quantitative, it is based on the nature of x. Whether x is qualitative, then the model is qualitative. If x is quantitative, then model is quantitative. But y must be always a quantitative. Model is generally called quantitative if the independent variable x is the model is generally called quantitative if the independent variable x is or are measurable. That means some physical measurement tool is there to measure the data is or are measurable variables. So measurable variables like such as time, so you can measure the time, you can measure the weight, okay, height, pressure, etc. So the model is generally called quantitative if the independent variable x are measurable variables such as time, weight, height, pressure, etc. If they are attributes means they are qualitative, such as color, varieties, types of machines, etc. Then such model is said to be qualitative. Such model is said to be qualitative. Qualitative model. In add the word model. Okay. However, but whenever you wish, you can convert the quantitative predictors into the qualitative predictors by grouping. However, qualitative models will allow for quantitative variables if they are used in a qualitative way. If they are used in qualitative way. For example, temperature in chemical process. So the temperature is a continuous variable. Temperature in chemical process, if you are taking the temperature as 50 degrees Celsius, 60 degrees Celsius, 70 degrees Celsius. Okay. So though the temperature is a continuous variable, but here you have taken the three groups. You are observing the process at the 50 degrees Celsius, 60 degrees Celsius, and 70 degrees Celsius, and you wish to compare at which degree of Celsius you can have the higher yield. So yield is a quantitative variable, but the temperature now is measured in a qualitative fashion. So that's why you can use the qualitative models rather than the quantitative models. Is that fine? So qualitative models is classified into the two parts. One is design model. The design model satisfies the definition of the general linear models, except that the rank of x is k. Rank of x is k, where n is greater than or equal to p is greater than or equal to k. So n is greater than p, greater than equal to k. P is the total number of variables in our study, but we say that when you find out the rank of the matrix x, x is of order n cross p. What is the order of x? It is n cross p. It should have a rank k. Rest of the assumptions are same. Y is observable, x is observable, but it is not random. The rank of x is equal to k. Epsilons are unobservable random variables whose expected value is 0 and variance covariance matrix is sigma. In addition, the X matrix of the design model consists of the only values either 0 or 1. That means when you talk about the design of experiment, what you are saying, whether the treatment is present or absent. So in a specific plot, whether the specific treatment is applied or not. If applied, the value takes 1, not applied, it takes value 0. That means the X is nothing but it is a binary matrix. So design matrix is always a binary, whether the treatment is present or absent. So what is the difference between the linear models and design models? In linear models, X is quantitative. In design models, X is a qualitative. Rest of the assumption are same. The design model has the matrix has the rank K, and the values of X are binary, either 0 or 1. When X matrix assume a certain pattern, when where X matrix assume certain pattern depending on particular design. So if it is a CRD, the X matrix has a certain pattern. If it is a RBD, it has a certain pattern. LSD, it has a certain pattern. So X matrix has the patterns according to the design, which designs you have adopted. Now the thing is, even you are studying the design of experiment, basic theory which we are going to use is a general linear models. So whatever theory we will study for the general linear model, same theory you will apply in the next semester when you are going to study about the design of experiment. Here the design model has the X has the certain pattern matrix which takes either value 0 and 1, and the rank of matrix X is a K, and the whatever the treatments we have selected in our design, they are fixed. So design models are also known as the fixed effect models. Design model is also known as fixed effect model. But suppose your the element of X, whatever the treatments you have taken, they are taking from a certain population. Randomly आपने choose किया 10 treatment में से 3 की comparison करनी है. So which 3 treatments are you going to compare? That is not fixed in advance. You are randomly select the 3 treatments and then you try to compare them. Then such model is said to be a random effect models. And the second part of this is nothing but a component variance of the model. So second, where the treatments are random. A component of variance models. Component of variance model. Again, it satisfies the assumption of general linear models, but few additions are there. The form of this model is similar to design model. Is similar to design model. That is xij x values either 0 or 1. So it is a design model in the way that the X matrix takes value either 0 and 1. A model in a simplest case to understand. A model in simplest case can be written as xij is mu plus tau I plus epsilon ij. In component of variance model, in design model, what we say that expectation of epsilon I is 0 and tau I is a fixed, where I running from 1 to आपके पास जितने भी treatment है, so I running from 1 to, if you are saying that let us say V treatment, and how many observation, j equal to 1 to n observation. That means experimental units are there. So xij is nothing but it is a value. Okay. So in components of variance model, tau I and epsilon ij. However, in a design models, treatment is a fix, and epsilon ij has a some random is a random variable which is unobservable, has certain distribution. But in component of variance model, tau I and epsilon ij are unobservable, random variables from distribution with variance. Mean is 0 with variance. With variances are sigma tau square and sigma epsilon square respectively. That is variance of tau I is sigma t square, tau square, and variance of epsilon ij is a sigma epsilon square. And the objective of this model is to observe xij and estimate sigma tau square and sigma epsilon square. In general, let an observable random variable it is a yij up to m be such that yij up to m. So there are I is a one factor, j is another factor. So let us say there are m factors such that it can be written as a mu plus a of I, b of j, b of ij plus up to epsilon I j m. यहाँ पे c of I j फिर w something like that up to j, where mu is overall mean, or you can say it is a some constant, ai is random variable. So AI itself is a random variable with mean 0 and variance sigma a square. Bij is another random variables. It is not interaction effect. It is just a another random variables. यहाँ पे आपने इसको treatment लिया. Let us it is a block. Both the treatment and block are random. Bij is also a is another random variable with mean 0 and variance sigma b square. Similarly, epsilon I j dot m is a random variable with mean 0 and variance sigma epsilon square. Further, it is assumed that AI, Bij, likewise other variables epsilon ij dot m are uncorrelated. They are said to be a uncorrelated. This specification, अगर आप ऐसी assumption ले रहे हैं, तो this specifications define components of variance model. So your basic aim is that you wish to find out the variance of each treatment. ठीक है? Up to any questions? Anyone?
No, sir.
So today we will keep up to this. In next lecture, we will add the assumption